Hello, I am Arunab, and today I am presenting Safesim, which is a system designed to bridge uh, the gap between complex medical records and patient understanding. In this project, we address critical challenge in healthcare domain, which is how much large language models can be linked directly to clinical notes and how we can have a patient safety ensured overall. So for this, we have introduced a neurosymbolic architecture that combines the fluency of modern AI with the strict accuracy of logical verification. Now, the motivation for this work was straightforward. While patients today have legal access to electronic health records, access does not equal understanding. Clinical notes are written by doctors for the doctors. They are dense, filled with abbreviations like QD or PIT, and use complex syntaxes. While we could use standard LLMs to translate this into plain English, there might be some context loss or even hallucination for sake. Let's take instead of 50 milligrams, it has been interpreted as 50 grams for some weird reason. Now, this isn't just a grammatical error; it is a potential medical emergency. We cannot rely on probabilistic model alone for this task. As such, to solve this, we propose Safesim. Instead of relying on a single black box model, we use neuro-symbolic approach. This means we treat the problem with two distinct components. First, the neural component, the LLM, which handles the creative task of rewriting text to readable context. Second, the symbolic component, a code based logic checker, uh, which enforces rigid constraint on medical facts. This allows us to achieve the best of both worlds, the readability of LLM and safety guarantee of a rule-based system. This slide illustrates our three-stage pipeline. Stage one, where we do the entity extraction, which acts as our ground truth. Stage two is simple, where we are doing simplification. We pass it through the generative AI model with the instructions to simplify the language for a layman. Step three is basically the verification. So whatever we took out from step one, like the ground truth, we are gonna rigorously compare it, do a set-based comparison for it, and then give you a score for it. As such, I want to highlight exactly how the verification work, as it is the core safety mechanism of our project. The logic checker implemented in our SRC verification module performs a mathematical set difference operation, as I stated. It compares the set of variable in the input against the output. For example, if the input contains 50 mg and the output contains 50 g, which is 50 milligram to 50 gram, the set do not match. Because the system is deterministic, it catches this certain hallucination that a human might miss. It ensures that while the words changes, the fact remains immutable. Now, to evaluate SafeSim, we compared it against two state-of-the-art sequence baseline models. First was BART large, and secondly T5 small. We measured performance across three dimensions. First is safety. Second is basically the like entity preservation and dosages. Secondly, simplification and quality based check using SARI metric and Fleshkin CAD grade level metric. And thirdly, text overlap with using Blue or Rogue to analyze structural changes. Here is an example where we can see it in action. The original text is telegraphic and jargon heavy. The baseline model tends to keep the structure rigid. Uh, SafeSim, however, transforms it into a complete grammatically correct sentence that explicitly states instructions like by mouth, every day, uh, the and etc. etc. This transformation reduces the cognitive load on the patient significantly. For a better detailed version, we can see on the side where all the key entities have been extracted for our need. As such, let's dive into the demo. So Here is our first thing, which is our UI. It has been made using Streamlit. You have certain categories here which you can choose from. In backend, you can either choose Dummy and Claude for the timing. While OpenAI is there, supported, you need to pass the API key for it. You can also change the strictness of how strict you want it. High means 100%. Medium means you can accommodate one error. Mid low means basically that no errors can be accommodated for it. As such, you can load some particular example. Here I have loaded hypertension one. And if you just simply run it, uh, let me load it again. Uh, yep. And if you just run it, we are going to get it like this. So even for hypertension, because it for some reason it wasn't able to load it, we can see that it is safe and validation score is 100%. So it preserved all the entities. If you want the visualization of it, you can just click on detailed analysis and you can see all the entities extracted as well as like what kind of safety insurance we have done. We can see that if anything is missing, everything will be recorded here. As such, let's go to another example. Now, this has been hosted as an UI as well as an API. So you can come to our docs link, which is our Swagger page. And this is our main post request where you can come down and pass your text, the backend, the strictness level, your API key, and the verbose. So once you pass it, we can see that we have to execute it. And once you execute it, you will be getting a similar output. Administer 10 units of insulin by injection under the skin 2 times a day before meal, and so on and so forth. While you will be getting all kind of matrices around it. As such, now coming back to our main point, this now this slide shows how verify loop works. We treat the LLM output not as a result, but more like an hypothesis. The system extracts entities from this simplified draft and runs a deterministic set difference check against the original text. As I mentioned earlier, if the data matches according to your strictness, it is verified. And all the mismatches are still recorded. You can get a hold of it, and if otherwise, if there are more than your strictness level mismatches, then it will be qualified as unsafe. This loop is symbolic guardrail that prevents the hallucination or any kind of misconception by the AI. Now, we compare SafeSim against other models. As stated earlier, SafeSim achieved 100% preservation for entities and dosages. The baseline only reached 99.7%, which is our default model where we are in like tying it up with Claude. That 0. Then is simplification that SARI score, we scored 0.453 versus parts 0.329, showing we are much better at simplifying complex phrasing. Our overlap blue score is lower. It's at 0.098, which I'm coming to in next slide. Now, our low blue score is actually a positive sign here. It confirms that we aggressively rewrote the text, which is stated by high Sari, rather than copying the source. We achieved a 2.74 times compression rate, cutting text length by nearly two-thirds while retaining 100% of the medical facts. The key takeaway from this is the neurosymbolic layer successfully caught errors that our LLMs generated or our deep learning models missed. Now, in conclusion, SafeSim proves we do not have to choose between readability and safety. We can have the best of both worlds. Our future works includes conducting a human in middle study where we can include some clinicians to validate our real world utility, which will help us generate some data too, which we can feed to our entity extractor to make it more versatile. Because there are certain instances where it still fails. As such, I thank you for your time today.